Hello. In this guide we will be installing SreC, but before we actually install SreC, an important note. When I tried to install it on a 3060, it did not work. It installed, but the outputs were wrong. But when I tried using an older architecture, I used a 2080 in particular, then this seemed to fix the issue somehow. So I used the exact same method, but just a different card, and this alleviated the issue. I am very confused about this. I find it strange, but I'm going to suspect that somehow SreC doesn't like modern architectures. So if you have a 30 series card or a more modern card, you can of course try installing it, but don't be confused if your outputs look wrong. And if possible, maybe you could try an older card. But with all that out of the way, let's get to the install. So the first step is to just clone the GitHub repo. So I'm going to use my own version here. It's SreC, but it also extracts the negative log likelihood and the entropy. But you can also use the normal SreC. Then just go to my GitHub repo and download the environment.yml. And with this environment.yml, we are going to create a conda environment. I recommend using conda here. It's quite comfortable to do so. It was reliable enough for me. And you can create the conda environment using this command. You can skip the naming part. I'm going to name a tutorial here, but choose your own name or just don't write any name. Then it's going to be called SreC. So it's finally installed. It might take a while. We are just going to activate this, so we're actually in that environment with this command. Now we are going to take a look at the install instructions provided by SreC. We basically already installed the requirement, so we are just going to install torquec. And here you can just copy paste the commands. So we first go into the source folder and then into the torquec folder. And then we just simply paste this. Don't be scared. The warnings here you can just kind of ignore. To verify if torquec was installed correctly, we simply use this command. It should return true. Now let's try following the instructions further and actually try SreC on a dataset. I'm just gonna quickly get the dataset. Now I'm just creating a folder to save the data. Of course, you can choose any structure on how to save the data you like. And here I'm creating a raw folder, a compressed folder, and a decompressed folder. Raw is for the actual data, compressed is for the SreC files after applying the encoding, and decompressed after doing the decoding. Now let's download the data itself. We have to unzip the data with this command here. Once it's done, we should delete the zip directory. So since we have the installation finished and the data ready, we can actually try running SreC. Here I recommend using the decode option. It basically just verifies if decoding the encoded version yields back the original, so the lossless image. And here I just paste it in. Of course, you need to adapt these parameters to your particular environment. And as we can see, it seems to be running well. Here you can again ignore the warning. And as you can see, we are currently running SreC. Depending on if you installed my version or the original repo, you will not see these print statements with the negative log likelihood. And the most important part here is probably just the images count, so you actually know how far you've gone. I think the open images dataset is like 500 images. So I'm gonna cancel this here. And now let's take a look at the results. And as you can see, we have these SREC files. And we also have these like PT files. If you use my implementation, you will have them. If you use the original SREC implementation, you won't have them. The .pt files are just like the negative log likelihood and the entropy that are saved. And yeah, that's it for the installation process. Now, if you're interested in the SreC paper, then the video is basically already done, so I'm guessing that's farewell. But if you're interested in the zero-shot detection of AI-generated images paper, and especially in my own method here, then this might be relevant for you. And actually, if you're from somewhere else, then I'm very, very confused on how you ended up here and why you kept watching, but that's nice, I guess. My implementation was actually done as my bachelor thesis, and as of recording this, the 3rd of December, they still haven't shared their code, so I kind of had to reconstruct their method, and I did so, but there were some challenges I should mention here. Probably the most important challenge was actually predicting the NLL and the entropy for all pixels. I only managed to do it in like 2x2 grids, and here I only predicted the top left, the top right, and the bottom left pixel. Notice the absence of the bottom right pixel. So here we are kind of losing almost 25%-ish amount of pixels. My results showed that that doesn't really matter that much, but of course these results should be investigated a bit more. I didn't have that much time to check them because bachelor thesis is only 3 months and re-implementing the method already took me quite a lot of time. So feel free to investigate this a bit more and use this as a like kick-off point for your own work. And again, this was done as a bachelor thesis, so I'm not a seasoned researcher like the authors of the original paper. So take this implementation here with a bit of a grain of salt. But I hope this implementation can be at least a kick-off point for you to work on. And yeah, if you want further details, I actually uploaded my bachelor thesis in GitHub. It's much more detailed, of course. And also the code for visualizing and working with the PT data I get is also uploaded. It's kind of a bit rushed because 3 months and not a lot of time, and I think you probably know how this goes. So excuse that, but I hope it can still help you somewhat and give you a bit of an easier time than I had because it wasn't an easy time.